Hey guys, this is Mr. Grice for Algebra Unit 9.3 Notes. Today we're talking about graphing quadratic functions in vertex form. Our learning target today is to be able to graph quadratic functions that involve shifts and reflections. Now, before we get started with some definitions, let's review some of the graphs that we've already talked about. Okay? First one that we have already discussed is this graph right here. What type of graph is that? Hopefully you're shouting linear. That is a linear graph. And I'd say congratulations, you are correct. Okay, another graph we talked about looked like that. And that is exponential. Another type of graph we've talked about looks like that. What is that? Are you saying quadratic? Because I really can't hear you. You might need to speak a little bit louder. Okay, so those are the three types of graphs that we've already discussed. Now, before we're done, we're going to add two more graphs. Now, not today, but soon, we are going to be talking about a graph that looks like that, and that is a graph about square roots. And the last one that we're going to talk about is absolute value. And an absolute value graph looks like that. So, 5 graphs total. One of the things you're going to need to know is you need to learn to graph fast without using a table. And that's what we're going to be talking about today. And we're only going to be talking about the quadratic graphs, okay? But one of the things you have to know, guys, is not only how to graph it fast, but you need to be able to match names and graphs and know what they look like. If we're talking about a linear, you need to know, oh, it just goes left to right. It's on a diagonal, okay? Exponential, exponential growth or exponential decay. Those are things that you're going to just need to know, okay? So let's go ahead and get started on our notes. Okay, so a parent function. A parent function is a common function in its basic form, okay? And some examples of that, if we were talking about a quadratic function, the most basic quadratic function would just be x squared, okay? If we were talking about square roots, well, we would just have square root and then an x. If we were talking about absolute values, well, the absolute value, remember that absolute value have those cool little lines and x inside, okay? So that's just the most basic form of the function, okay? Now, today we're going to be talking about shifts, okay? And the two types of shifts that we're going to be talking about is that there could be a horizontal shift. Now, a horizontal shift means from left to right, okay? The other type of shift we could have is a vertical shift. And the vertical shift would be up and down, okay? And that's movement of a function when compared to its parent function, okay? So if we have a new function, we would compare it to the basic one just to know what it looks like, okay? Now the reflection over the x-axis is when a function is flipped, okay? Flipped, okay, and that would be a vertically, okay? A vertical change. Another way to think of it is if it is upside down, okay? We are not talking about horizontal shifts. There are horizontal shifts, but let's go back to this guy right here. So, nope, not that. So, here's an example. If we had our normal graph of, let's say that's our normal graph. If we're saying, hey, it's flipped, it would be a mirror image of itself. So all we really did was kind of flip it upside down. Okay, does that make sense? And a horizontal shift, which we're not going to be talking about, is if we had a graph that looked like that, the horizontal shift would be going the other way. But you don't have to worry about that in this class. Okay? So, back to the notes. All right. Our parent function, f of x equals x squared. If we were to graph this, the first thing we would do is we would start by filling out our x, okay? And remember, we put 0 in the middle, and we would have -1, -2, and 1 and 2. What I want you guys to do is go ahead, and we're going to do this without a calculator, okay? Because remember, when we're plugging this in, we would plug in whatever x is. So -2 squared, what's -2 times -2? 4. Then we would do -1 times -1, which is 1. 0 times 0, 0. And then these are going to be the exact same as the others. Okay, because we're talking about quadratic. Remember that those match, and in the middle, what do we have in the middle? We have our vertex. All right, let's go ahead and plot this. So we got 0, 0, -1, 1, -2, 4, and then we got 1, 1, and 2, 4. And then remember to graph it nice and pretty. Now, if you're in class, we talked about using graph or tracing paper, and to go exactly and just graph the line, trace the line on your paper. And we'd show you something pretty cool. I can't really show you because I can't jump into the computer and show you trace paper and stuff like that. So if you got questions on it, come see Miss Carranza or myself. Okay? Now, let's talk about the transformed function. Now, this is going to be the last time we let you use your calculator. Okay? What's our vertex? Let's start with the vertex first. Okay, we always want to start with the vertex first. Remember, we take the opposite and then the 2 stays the same. Okay, this is in vertex form. So our vertex is -1, +2. Okay, and then we would go 2 numbers below and 2 numbers, 0 and 1. Okay, so ready? Enjoy the last time you're going to get to use your calculator for a while. I want you guys to plug those numbers in and tell me what you get. Go ahead and pause the video, and good luck. Okay, and you should have gotten -2, 1, 2, 1, and -2. So what we're going to do is, once again, we're going to graph those. Where we got -1, +2, 0, 1, -2, 1, and then -3, -2, and 1, -2. And then graph your line. Now, if you notice, if I was capable of flipping this around, those graphs, those two functions are very, very similar. It's just one, they're kind of flipped around and moved a little bit. That's what we were able to notice on our calculator using the tracing paper. Okay, that you're able to figure out what the pattern is. That's what the transformed means. that it's either moving up or down, left or right, or it's a reflection. And that's what we can tell just by looking at the function. Okay, so let's start with the a. Okay, the a up here is going to tell us two things. Now, what are those two things? Well, if a equals 1, this is going to tell us what our reflection is. Okay, so this means that there's no reflection. Okay, it opens up. If you like to draw what it looks like, that's what we'll do. Okay, and if a equals -1, it means that there is a vertical reflection. And the vertical reflection means that it opens down. Okay, now I'm just going to scroll up real quick. Was there a number in front of the x? No, that means that it is positive. And what was the number in front of the parentheses? A negative. When it was positive, it opened up, and it was negative, it opened down. That's the first reflection that they're talking about. Okay. Now, next thing that we're going to be talking about is the h. Okay. And the h tells us about the horizontal shift. So the horizontal shift. Now, in the original equation, h is negative. And if h is negative, we're going to move to the right. Okay, it's kind of the exact opposite of what we would think. And if h is positive, we're going to move our graph to the left. Okay, so as you look at that real quick, I'm just going to zoom out so we can kind of compare horizontal left to right. So we didn't have anything in our first equation, our parent function, which means we didn't move left to right at all. It's a 0, okay? But here, it was 1. So that means it's a positive 1, which means we move to the left 1 spot. And if you look, our vertex moved to the left 1 spot. So that's all we're looking at that first part. Okay? And now our last part, which is the k, the k tells us the vertical shift. Okay, so the vertical shift, if we have a positive k, that tells us we are going up. And if we have a negative k, that means we are going down. Okay, so when we're looking at the 2 again, +2, and this one was 0. So 0, it didn't move. It's right there. But here, it said that it's +2. Look at where we're at. We went up 1, 2. We went up 2 lines because of that +2. Okay? So we're able to tell a lot of things just by looking at the equation. And remember, the first thing we always need to do is find the vertex, okay? Write yourself a note that we always need to find the vertex first. Very important, okay? All right. So I know that the vertex is the most important thing, and for some reason it's on the bottom here, but that's always going to be the first thing we look at, okay? So our vertex for the first equation, for number 1, remember we take the opposite, and this stays the same. This is the last time I'm going to write this. Okay, so the opposite of -3 is 3, and the 4 stays the same. Okay, so the next thing we're going to look at is I'm going to look to see if there's a reflection. And that's where I look at the number in front of the parentheses. Is it positive or is it negative? Okay, it's positive, which means that there is no reflection. And just so I know, that means it's going to open up. Now, the next part, the shifting, you guys might be like, whoa, Mr. Grice, what are you talking about? Let me show you. Okay, so let me draw what we've got. I'm not going to draw the entire graph, but we have, this is where we normally start, okay? That is the parent function. Remember where we start every single time? But our new graph has us starting at the point 1, 2, 3, 1, 2, 3, 4. I want to know, how do I move from here to there? Oops, let's keep that. So the first thing I want to know, how many to the right did we go? That's our horizontal shift, okay? So the horizontal shift tells us that we went 3, right? So we went right 3, okay? Because we take the opposite of the horizontal shift, and the vertical shift is that guy right there. So we went right 3, and then how many up did we have to go? We went right 3, and then we went up 4. Okay, and that's telling us what we're doing. Let's look at the next one. Vertex. What did we get for the vertex? Okay, we take the opposite of 5, which is -5, good. And then -7. Okay, so then one at a time, let's look. Is there a reflection? Yeah, there's a reflection. And that means it's a vertical reflection. So now it's going to be going down. Okay, horizontal shift. What's that telling? Are we going to move right or are we going to move left? Well, look at your vertex. Your vertex tells you right here. It's negative. So that means that we are going to go left, and we are going to go left 5. Okay, and the vertical shift, that -7 tells us. And that -7 tells us that we're going to go down 7. Okay? Now, number 3 looks a little weird. It's like, Mr. Grice, that's not vertex form. I know. But what it's saying is, if it were inside the parentheses, it would be x plus 0 squared plus 1. All they did is simplify it. Okay? If there's no parentheses, that means it's saying x plus 0. So our vertex, because there's no opposite of 0, would be 0, 1. Now, see if you can answer the rest of the questions. Go ahead and pause the video, and good luck. Okay, and there we go. So the reflection, there is no reflection because it's positive. The horizontal shift is none because it doesn't move left to right. Okay, and guys, if you're having trouble with that, look at your vertex. Okay, the horizontal shift is your x, and then your vertical shift is your y. You always want to relate it back to the beginning over here. And if for a couple of these, if you need to come out and redraw these and say, all right, so I've got the point 0, 1, there's 0, 1, Oh, sorry, that's not 0, 1. There's 0, 1. All we did was go up 1. Can you guys see that? Okay. Well, this video is getting a little long, and guys, we're only on the first page. Okay. So I'm going to stop it right here. This will be the end of video 1, and the back page will be video 2. Now, if you have any questions, please come see Ms. Carranza or myself. We would love to help you out. This is Mr. Grice signing off for Algebra 1, Unit 9.3 Notes, Video 1. Thanks for watching.